All right, y'all. So this week we're going to be going over what's called mega FRQs. So College Board has announced that there will be two FRQs this year. One that's going to be 25 minutes long, and one that's going to be 15 minutes long. So a lot of the calculus teachers have kind of started calling this 25-minute long FRQ a mega FRQ. Now, College Board has not released any official mega FRQs, but a couple of College Board teachers or different calculus teachers have kind of created their own, just kind of guessing. So I've given you about 5 of them this week. They kind of vary widely on what they cover. So unfortunately, I'm going to go over this one in the notes, and the other 4 are not going to be just like this one. But, with all the stuff we've been doing before, I'm hoping this week you should be able to, pretty realistically march through most of these FRQs without, my guided help. But this one's going to be pretty straightforward. It's a particle. We're given the velocity equation. We are also told, that the position function is x of t, and we know that x of 0 is equal to 7. So that's that initial condition that they give us. All right, so on part A, on the interval 0 to 4, when is the particle moving to the right? Give a reason for your answer. All right, so particle moving to the right would mean the velocity is positive. So I need to know when the velocity is positive. Now, testing everything would be too much. So what would be a really easy thing to do? Find our critical points, and then be able to set up our test interval. So I can set the velocity equation equal to 0. So v of t is equal to 3t squared minus 8t plus 4. So 0 is equal to 3t squared minus 8t plus 4. And then I want to go ahead and factor this out. So 0 is equal to... And then we can test a couple of things out. We do know that we want this to add up to -8. So we can split 4 into -2 and -2 because we know our middle number has to be negative. And then we have t and t. Our only factor of 3 is 1 and 3. So one of these needs to have a 3, and one of these needs to be just the 1. So 3t times -2 is -6t. T times -2 is -8t. -6t plus -8t. -6t plus -2t is -8t. So we're all good to go. Right? So then that gives us 3t minus 2 gives us 2/3 as our value of t. And t minus 2 gives us 2 as our value of t. Okay. So now that we have our critical numbers, remember our critical numbers are when our derivative is equal to 0 and v of t is our derivative, then we can go ahead and set up our test intervals. So positive 2/3, positive 2. So let's pick some numbers to plug in. We can do v of 0, which would be to the left, v of 1, which would be in between, and v of 3. Okay. And as it says up above, you can use a calculator. You can also do these by hand. Either one is fine. I'm going to use a calculator because I'm a lazy bum for some of these. But you're expected to be able to do them without a calculator, but they're also not limiting you from having a calculator. So have a calculator available. Use it when you need it. Just make sure you still show all of your work. You saying v of whatever equals a number, that's not necessarily you not showing work. You've already shown all the calculus work, which is what they're really concerned about. So v of 0, if I plugged in 0, first 2 terms would cancel out. So that would just be 4. So we do start out positive. All right. Then v of 1 squared is 1. So we have positive 3 minus 8 times 1. So -8 plus 4. 3 minus 8 is -5. -5 plus 4 is -1. So that's going to be negative there in the middle. And then positive 3. 3 squared is going to be 9. 9 times 3 is 27. 3 times -8 is -24. So 27 minus 24 is 3. 3 plus 4 is 7. So that is positive. So we get positive, negative, and positive. So then let's answer our question. When is the particle moving to the right? Well, it's moving to the right anywhere we are positive. So negative infinity to 2/3 and 2 to infinity. So, but before I move on with that, we are only being asked on the interval 0 to 4. So can I limit it from instead of negative infinity to infinity to just 0 and 4, I should. If I don't, I'm probably going to lose a point on that. So 0 to 2/3, and we don't want to include that 2/3, in union with 2 to 4. Now I can't include 0 and 4 because I know technically it keeps going to the right past 0 and 4. So I do know it's also moving to the right at 0 and 4. So that's why I can include those. Now, last piece, I do have to give a reason. And my reason for that answer would be because v of t is greater than 0. Because when velocity is positive, it's going to be moving to the right. Pretty straightforward and simple. All right, part B. On the interval 0 to 4, when is the particle moving to the left? Okay, just same question, but going the other way. So what's the only interval that's left? 2/3 to 2. So 2/3 to 2. And we still need to justify, so because v of t is less than 0. Same question, just opposite direction. All right, part C, we want to find the average acceleration of the particle on the time interval 0 to 4. Okay, remember, we have two different equations we can use to find average. We have average rate of change, and then we have average value. We use average rate of change when we want to find the average of the function we don't have, the next function up in the order. Okay, average rate of change is just another way to find slope, and slope is derivative. Average value is when we want to find the average of the function we have. That's our 1 over b minus a times the integral from a to b. Well, we don't have acceleration, and acceleration is the derivative of velocity, so I'm going to use average rate of change for this one. So I'm finding it from 0 to 4, so I'm going to plug in my f of b minus f of a over b minus a, so v of 4 minus v of 0 over 4 minus 0. And for v of 4, we get 20. So 20 minus v of 0, we found 4. So 20 minus 4 over 4 minus 0, which gives us 16 divided by 4, which is just equal to 4. And does it give us anything about units? It does not. So average acceleration is just 4. And it doesn't ask us to justify, so we don't need to justify that we know that, even though, I mean, our justification is our work in this case. All right, part D, we want to find A1, the acceleration of the particle at time t equals 1. So the difference between finding the average acceleration and finding the specific acceleration at a point, now I want to know the derivative. I want to know that instantaneous rate of change. So this is IROC. So to find IROC, I need to find the derivative. So I need to take the derivative because v prime of t is equal to a of t. So v prime of t would be equal to my derivative of 3t squared. That's going to be 6t. Then derivative of minus 8t is going to be just minus 8. That t goes away. And then the derivative of positive 4 is going to be just 0. So our v prime of t is equal to 6t minus 8, which is the same as a of t. So if I wanted to find a of 1, I'm just going to plug in that 1. So 6 times 1 minus 8, we get 6 minus 8, which equals negative 2. And once again, we do not have any units, so we don't need to worry about tacking anything on there. All right, part E. Hey, they just repeat the question up here at the top, just in case, so we don't have to scroll all the way back. Is the speed of the particle increasing or decreasing at time t equals 1? Give a reason for your answer. Okay, so I want you to notice the important change of verbiage here. Speed. Okay, so speed is different from velocity. Speed is just about, is it getting bigger or is it getting smaller? It's the speed. Okay, it is what is the miles per hour on your car. It doesn't care what direction your car is going. It just cares how fast your car is going. Okay, so I want to know if the speed, the number, is getting bigger. Okay, now velocity and acceleration take into account the direction. So for my speed to be getting bigger, for that number to be getting bigger, then my velocity and my acceleration have to be occurring in the same direction. If velocity is positive and acceleration is positive, then I'm going to be going faster in the positive direction. If my velocity is negative and my acceleration is negative, then I'm going to be going faster in the negative direction. If they are opposite signs, then I'm going to be slowing down in whichever direction I'm going in. Okay, so to find this, I need to find velocity and acceleration at 1. Well, we already know the acceleration at 1, so I just need to know the velocity at 1. So v of 1, I believe we found v of 1 up above. We did. So v of 1 is equal to -1. And we know that acceleration at 1 is equal to -2. So they're both negative. So does that mean our speed is increasing or decreasing? Speed is increasing. And that is because a of 1 and v of 1 have the same sign. So anytime they transition over to speed, and they're asking if the speed is increasing or decreasing, it's always going to be the same idea. We need to show that velocity and acceleration have the same sign. If velocity and acceleration don't have the same sign, they're going to be decreasing. If velocity and acceleration have the same sign, they're going to be increasing. Doesn't matter if it's both positive or both negative. That's just telling us the direction it's increasing in. But if it has the same sign, then it's going to be increasing. If they have different signs, it's going to be decreasing. Always and forever. All right, F, find the position function x of t for the particle. Okay, so we're going to position. We have velocity. We got to go backwards to position. So what's our backwards formula? That's going to be our integral. So I want to integrate. So x of t is equal to the integral of v of t dt. So x of t is equal to the integral of 3t squared minus 8t plus 4, or at least I believe that's our equation. Yep. dt. So we're just going to integrate. So x of t is equal to 3t squared. That's 3t cubed over 3 minus 8t squared over 2 plus 4t plus c tacked on there at the end. 3 is going to cancel out. 8 and 2 becomes 4. So x of t is equal to t cubed minus 4t squared plus 4t plus c. Okay, now we do still need to solve for c if I want to find the actual position function x of t. Well, luckily, they did give us an initial condition that x of 0 is equal to 7. So 7 is equal to 0 cubed minus 4 times 0 squared plus 4 times 0 plus c. Well, all that's going to cancel out, so we get 7 equals c. Then we can just plug that back in. So x of t is equal to t cubed minus 4t squared plus 4t plus c. Just like that. Hey, now part G, we're going to use the function you found in part F to find the values of x of 1 and x of 4. Well, that's easy. I just need to plug in 1 and 4. So now that I have 1 and 4, x of 1 is equal to 1 cubed minus 4, 1 squared plus 4 times 1. Oh, I forgot. I need to actually write the 7 in my answer. Okay, so plus 4 times 1 plus 7. So that gives us 1 minus 4 plus 4 plus 7, which equals 8. Equals 8. Then x of 4, we get 4 cubed minus 4 times 4 squared plus 4 plus 7. So x of 4 is equal to, that's 64. 4 times 4 squared, that's just 4 cubed, so minus 64 plus 4 plus 7. So we get 64 minus 64 plus 16 plus 7. That 64 and 64 are going to cancel out. 16 plus 7 is just equal to 23. So we get x of 1 is equal to 8, and we get x of 4 is equal to 23. All right, now last but not least, part H. We want to find the total distance traveled by the particle on the time interval 1 to 4. All right. Now, for finding total distance, we've talked about this before. What's the difference between total distance and actual position? Well, total distance, kind of like speed, it doesn't care about positive or negative. It just cares about distance traveled. So if I don't care about positive or negative, then I just want to make everything positive. So, go away. So we want to find the integral from 1 to 4 of the absolute value of v of t. So 3t squared minus 8t plus 4 dt. All right, for our total distance traveled. Now, one thing you might notice is that we're integrating an absolute value function, and we don't technically know how to do that by hand. Now, like I said, you're not supposed to, well, they're supposed to give you questions that don't require a calculator. You can do this one without a calculator. I'm going to show you how to do it without a calculator as well. But also, if they gave you a question like this and you have a calculator, you should just use your calculator. So we'll move forward with the calculator one first, and then I'll show you the non-calculator version. So the calculator version, just going in here, I hit math, and then I'm going down to option 9, that function integral. So I want the integral from 1 to 4. Then I need to get that absolute value. Well, absolute value is also in the math, so hit math, and then I arrow over to the num, and it's that first one, ABS, and it should get you the absolute value sign. So 3x squared minus 8x plus 4 dx. It'll take it a bit, but it gets practically 17. So 17, because even if we rounded that to 3 decimal places, it's still 17. Right, so that's the shortcut easy way. And I don't really see any reason why they can't give you credit for that. I mean, that's what the absolute value is. You have a calculator. Now, the longer way, if you don't have a calculator, or if you just want to be sure and be like, Mr. Bone, I got some spare time, I can use it. Well, we can also kind of work backwards to find that position traveled, right? So remember from earlier, we made our sign chart for v of t. From 0 to 4. Well, now we're going to make it from 1 to 4. And the only critical point we had from 1 to 4 was 2. Okay. Remember, we had 2 critical points, 2/3 and 2. Well, 1's going to be on the right side of 2. So then we're going from 1 to 2, and we're going from 2 to 4. Well, from 1 to 2, it's going to be negative, and from 2 to 4, it's going to be positive. So negative and positive, which this isn't too terribly important, but we'll kind of talk about it. Well, we already know that the position at 1 is 8. We found that earlier. And we know the position at 4 is equal to 23. The only other position I need is going to be the position at 2. And you're going to see why here in just a second. So x of 2 is equal to 2 cubed minus 4 times 2 squared plus 4 times 2 plus 7. So this gives us 2 cubed is 8. 2 squared times 4, that's negative 16. Plus 8 plus 7. So all that's going to cancel out, and we're left with just 7. Okay, so on our interval, we have at times 1, 2, and 4. Our position is 8, 7, and 23. So this lines up with what we know. We know that we're moving to the left, so we should go backwards in our position where our particle actually is, and then after that, we start moving to the right. So that's why we increase from 7 to 23. Well, what I'm really concerned with is the difference between these. So between 8 and 7, how much distance is my particle traveling? Well, it traveled 1, whatever units we're worried about. Then between 7 and 23, how much distance did it travel? 16. Okay, Well, if it traveled 1 and it traveled 16, what's the total it traveled? 17. Okay. So we can also use, what we know about our sign charts and what we know about our particle moving to also calculate that total distance traveled. Because even though this is technically, backwards 1 and positive 16, backwards 1 and forward 16, I don't care. I just care about everything being positive, adding up those values. So think about it like we absolute valued both of these, and then we just added it up to get 17. All right, and that should take your first mega FRQ. Notice it probably won't take you exactly 25 minutes to do all of them. Some of them are going to take a little bit more time than others. You will have 45 minutes total, I believe, for the test. 40 minutes for the 2 FRQs, so 25 and 15, and then 5 minutes of upload time is kind of what they're giving you to make sure that you can troubleshoot everything. So like I said, this one's not going to be just like the other 4 this week. So please ask lots of questions in the homework discussion, and then make sure you pay attention for next week's breakdown video. All right. Thank y'all.